In this short video, we'll have a look at basics of making functions in Matlab based on examples. So in the first example, we'd like to build a function which takes in a vector x as an input argument, and then it takes in some kind of limit value t, and based on that, it removes all the elements greater than t from x. So if we have numeric examples, these are vector x, and our limit value is 5, then we would like to remove the 7 and 6 from here because these are the two which are greater than 5. Okay, so then the resulting vector, which is the output argument, would be valued like that. So it has 2 elements less in this particular case. So let's go straight to Matlab and see how this is done. Quite often, in order to test that the function works correctly and it does what you want, the easier way is to first write a code, just a simple script which does the job, and then you convert that script into a function. So that's what I will do in here, because I think this is, especially at the beginning stage when you're still learning to fix mistakes in the codes, this is quite useful in this way. So as we discussed, we were to do it on a vector x, which has some values, and then it has some limit for which we will do the elimination, and let's keep it 5 as we had. So now the actual job of creating the new vector which satisfies the condition or in which a portion of elements are removed, this can be done in 2 ways, using logical indexing or a loop. Just without too much explanations, I'll write both for your benefit. And of course, logical indexing is the better one, but if you feel that loops are naturally easier to understand for you, then it's okay to use a loop as well. So without a loop, I want to find, or I want to not to have in my resulting vector elements greater than 5, which means that I want to keep those which are smaller equal 5, or in this case t, because I have predefined t to be 5. So this condition in here first determines for which elements in my vector this statement is true, and I want to keep the elements which are respective to those which are true in here. So I want to keep 1, 4, 5, 3, and 0. And of course I want to keep the values and not just the true-false values, or maybe not the locations. So I know that the values are there in our x vector. So in this way, we say that from vector x, we pick those elements for which this condition is true, so for which the value is less or equal to 5. And all is left is to assign this result, because now if I run it, it goes to variable ans. What we need is to assign it to variable, whatever we want to call it, and I'll call it y. So the job is done. If we were to do it using a loop, we would need a loop which visits all the elements of our vector and then looks at them one by one, and if that element satisfies the condition again, so if it's not greater than 5, then we want to keep it into vector y. I'll call maybe this y1. So I don't know in advance how long my y1 vector will be, that's why I define it empty, and I will be extending it one element at a time when I find an element in x which satisfies this condition. So I will say that if that particular ith element of x is less equal 5, again not 5 but t, I want to keep it, so I want to put it inside my y1 vector, that particular xi. I don't need any else, because if the condition is not true, then I just ignore that element and I move forward and check another one. So this is a loop version of the same solution. I will not run it here, but it does the same job. Or for verification, let's just have a look. So we run, and then let's combine y and yt as 2 rows in a matrix. Sorry, not yt, y1. and then you can see that we have the very same outputs from both. Okay, so now all we have to do is convert this simple code into an actual function. So function always starts from function definition line, and that means we start with word function spelled like this, so that it starts with small f, and when it's spelled properly it's all blue. And then we had first the output arguments. The only output we really want from this code is y, so the resulting y vector. Then we have to give the name to our function. So I will call it throwaway, because it throws away some elements. And then in parentheses we give input arguments. So what was needed for this to be done is the vector x on which we do the job, and is the limit t that defines what is being done. So I put x and t. I could have put them the other way. The order doesn't really matter in here. It matters once you've defined your function, the order matters when you call it. Okay, and since I have the function in the same script that I will want to call it, so I have to end my function with end in here. So now if I run it, nothing will happen, because even though I defined the function, I don't call it. It even emphasizes here this function name in orange and suggests that maybe this function is not being used, and it is not, because I defined that kind of test cases for which I will test it, but I haven't called the function. So what I do is say here, and I don't have to call it y anymore, I will call it capital Y, for instance. When I call the function, of course the name of the function has to be correct, so throw away. And then I put my inputs, again to show you and remind you that naming of the arguments doesn't matter. What matters is the order. So x1 and t1 in here. So now my y, into which I ask Matlab to assign my output, will be having that resulting vector. If I made a mistake and changed the order in here, so first I give the limit and then I give the vector, then we might be getting some errors, yes. And it starts to complain, logical indices contain true value outside the array bounds, because now t, what used to be t in the function, Matlab thinks that t is now here in the place of the vector. Okay, so let's fix it back, and that's it for this example. If you want to extend it, for instance, you would like to throw away elements which are below one limit and above the other one, for instance, so we throw away whatever is above 5 and whatever is below, say, 1. So you can add it as an extra input. I will call it maybe t lower, t upper. So whatever is, so it means that I want to keep whatever is less equal the upper limit, and at the same time, so we just combine logically the logical indexing, x greater equal t lower. So now this will determine that our resulting vector, oh yeah, now it says not enough input arguments. I wrote my function to have 3 inputs. I have forgotten to pass the second input argument in here. That's why this error comes in. I put t2. So now for this given vector and these two limits, anything between 1 and 5 inclusive will remain in our y vector, and everything else will be removed. So still not, it says, so from x, if it's okay, yes, result is empty. I wanted to make this so fast that I didn't notice. In here, I have placed upper limit first and lower limit first. So Matlab treated this as upper limit and this as lower. So I said anything that is less equal 1 and at the same time greater equal 5, which is mathematically not possible, I want to take it in. So that's why this resulting vector is empty. So what I have to do is either swap it here or here. So my lower limit is 1, it's t2, and upper limit is 5t1. So now let's run again, and now we have the correct output.